Hello, this is Paul from Foresight Tech. In this lecture, I'm going to review the symmetry of a function. For the symmetry of function, basically we have two types of symmetry. Okay, for functions. Okay, keep in mind. So the first type is like this. The graph is like this, which means the graph is symmetrical, but the y-axis we call the even function, right? And the second type is looks like this, okay, and the graph is symmetric about the origin. Oh, here we call the odd function. So in mathematics, so how to define? So we define an equation. Can you see? F negative x equals f is even y. Okay, because when we change x, this point, the symmetric point is the image is there, which means when we change x to negative x, can you see the y? F at negative x keep the same as f at x, the same y, right? So the same y. This is symmetrical about the y. So we use that definition. How about the other functions? When we change the image of this point that goes to here, okay, that's when we change x to negative x, the y, can you see? The y value goes to opposite. Opposite, which means the y value goes to negative fx. So can you see from the graph? That's the definition. Example, we have a lot of examples. For even function like a cosine, for other function like a sine, right? You learned before. If we know the graph, it's very easy to determine is even or odd. Okay, look at the symmetry. If we don't see the graph, how to do? So the basically use this definition. Okay, evaluate f at negative x. If equals the value at f at x, that's even. If it's opposite to that value, is odd. If it's not both of them, means not even, then not odd. Okay. I have two examples to show you. So the first, can you see this? How to evaluate? How to describe the symmetry? It's even or odd or neither of both. We have the definition. Do you remember? So all we need to do is evaluate f at negative x. Okay. In mathematics, that's the basic. So we're going to do this. Evaluate f at negative x. All we need to do is evaluate, and then compare these to fx. Right? How to evaluate? Change the x to negative x. So negative x, negative x. Don't miss the parentheses. Plus 1. So here, can we see? Now can we compare these to the original function? Of course, we need to simplify. What does it mean? Negative x squared equals x squared, right? And this negative we put out. So what do we get? So definitely we will get this. This negative, I still put a negative here. X is there. Negative x squared is x squared. Okay, plus 1. Now we can compare this to the original. This is the opposite of the original, right? Okay, negative at f. This is a negative at negative fx. Okay, original equals the opposite. Do you remember the definition? Is the odd function. So now we make a conclusion. This function is odd. What the symmetry? Odd is symmetrical about the origin, right? So that's symmetric about the origin. Okay, this is the first question. Look at the second question. One more. Here. We still don't have the graph, so evaluate f at a negative x. That's all we need to do. So we're going to evaluate f at a negative x. So this time, change substitute x by negative x. Replace x. Do you think it is correct? No. Don't miss parentheses. Okay. Otherwise, it's wrong. So this x is negative x. So the bottom is negative x. Don't miss the parentheses. Okay, 4 plus 1. simplify, of course. Simplify, then we can compare. Otherwise, it's too complicated to compare. Simplify, negative goes to positive, right? So even power is positive. So this is positive x squared. This is the same. What do we get? We get here x squared, x fourth power plus 1. This is after simplification. Okay. After we simplify. So we get this. Now we can compare. Here is exactly the original f, right? It's the original function, which means equals f at x. F negative x equals fx, which means what? Even function, right? So now we find it is even. Okay. What's the symmetry? The symmetry is a symmetric about the y-axis, right? About the y-axis. Okay. So that's all. Thank you.